Hi, Mr. Martuziak here, and right now I want to talk to you about patterns that we're going to see on the periodic table. Now, some of the basic trends that we're going to be talking about are atom size, ion size, reactivity, ionization energy, and electronegativity as well. Now, starting with atom size, as we move up and to the right on the periodic table, atoms get smaller. Here's a nice diagram to show the size of the atoms visually here. So let's talk about what we see and why we are seeing it this way. Again, protons have a positive charge, and protons are found inside of the nucleus of an atom. So the protons are pulling in, they are attracting those electrons. Remember, opposites attract. So these two opposite charges are attracting each other, so those protons are pulling in those electrons, and so they're making a nice, tight, small atom. Okay. Now, as we look down a group, or a column, okay? As we look down a group, we see that the atom sizes start to get larger. Let's talk about that. The reason being is because as you go down a group, we're also increasing in our energy levels. And energy levels, as those numbers increase, we get farther away from the nucleus. And so those valence electrons, those outermost electrons in those larger energy levels, they're farther away from the nucleus. And so the pull or the attraction of the protons is a lot less on them. Not to mention all of the other electrons that are forming all of those subshells before it, those are forming a sort of defense for the valence electrons and the pull that the protons are pulling on all of the electrons out there. Now let's talk about ion size. Now we have two types of ions. We have cations and anions. We're going to talk about cations right now. Now cations have a positive charge. And you're going to find your cations with your metals. Now cations, they are smaller than the neutral atoms from which they're formed. And the reason being is because metals, they're going to lose electrons to form their ions. That's why they become more positive. And so because metals lose their outer energy level to form cations, when we say outer energy level, referring to the outer electrons, this causes them to be a lot smaller. Now anions are ions that have a negative charge. And we're going to find these in our nonmetals. Okay, so now these are going to be a little bit larger because we're adding more electrons. So since we're adding more electrons, this atom's getting larger. Okay, now not just because we're adding more electrons, but because as we add more electrons, this will also cause a repulsion, and the electrons will spread out more. Because remember, opposites attract, right? But when we add more electrons, which they're all negative, they're not attracting to each other. They're pushing each other away. So they're going to cause a more larger, spread out atom. Now, chemical reactivity, we kind of already touched on, but we'll go over it again here. Again, as we're talking about valence electrons here, and as atoms go down a group, and they'll get larger, okay, the reactivity, the amount of reactivity they will incur will become larger. And that's because the valence electrons, again, are farther from the nucleus. And therefore, they're not attracted to the nucleus as much, and so they're a lot easier to remove. And when you remove them and you're able to share them with other atoms, then you have these chemical reactions occur. And so that's why, as we look down a group, we can see the chemical reactivity increases more and more and more. Now, ionization energy is the amount of energy that is required to remove those valence electrons from an atom. And that also, as we go to the right and up on our periodic table, we will see that increase. And so, in larger atoms, the valence electrons, again, those outermost electrons, are farther from the nucleus. Therefore, they have less attraction to it. We can see this same pattern occurring over and over again about electrons being far from the nucleus. So large atoms have low ionization energies because those electrons are so far away from the nucleus, you don't need a whole lot of energy to remove them. But the small atoms, they have a lot more. Let's take a look here at a flow chart that's going to show us the ionization energy. And what we're going to be looking for is big jumps in ionization energy, large increases from one level to the next. All right, so let's take a look here. Now, in this table here, let's take a look at lithium. Alright, so let's take a look at lithium here. And the first level, 520 kilojoules per mole. And the second level is 7,300. Okay. And then the third level is 11,815. So what we're seeing here is a huge jump in ionization energy. So you're rarely ever going to see the electrons in the second level there removed for lithium, and for the first, it's not going to happen. It's just not going to happen. Those big jumps, 520 to 7,300 kilojoules per mole, that's a huge jump. It's basically impossible, but you know, I say nothing's impossible. But as we can see there, most likely those will not be removed. It's going to be the outermost energy levels. All right, so take a look at that chart, see if you can see any more that you see some big jumps, and think to yourself, wow, those electrons are not going to be able to be removed. Another good one would be nitrogen, number 7 there. And we look in the 5th level there, that 5th column, 9,400. Okay, the 6th column, 53,000. So again, that 5th level, those electrons are not going to be removed. All right, it takes a lot of energy just to remove the 6th, but so as you look at the 5th, not so much. All right, if you have any other questions, please ask them in class. I'll see you next time.